For years, artificial intelligence has functioned primarily as a conversational interface, a system answering questions but leaving the execution of complex tasks to the user. This Oracle model creates a constant friction. Users are forced to prompt a cloud-hosted model, copy the text output, and manually move that data between isolated applications and local files. Claude Cowork changes this interface from a chat box to a task runtime. It is built to move past text generation and toward direct, multi-step execution. This environment is known as the Agentic Workspace. Here, the AI can read disorganized folders, modify local documents, and operate native software applications on its own. When an AI transitions from providing advice to executing workflows, it becomes an active digital worker, altering the way humans interact with their computers. An AI with the authority to read unvetted files and execute local commands can automate digital logistics that previously required hours of manual effort. But this autonomy introduces a specific engineering risk. If an LLM is granted the power to modify a system, it also gains the potential to corrupt it. The challenge is connecting a cloud-based reasoning engine to a user's local desktop without exposing that machine to total system failure. To solve this, Anthropic isolates the AI's actions inside a local virtual machine, restricting its interface to a constrained visual sandbox. Understanding this exact physical structure explains why the tool is both a significant force in the software market and a new category of security threat. The foundational security rule is that the agent doesn't run freely on your host operating system. Instead, as this schematic shows, the agent lives entirely within an isolated Linux virtual machine on the user's hardware. All file modifications and sub-agent processes are contained within this virtual boundary to prevent a failure in the sandbox from affecting the rest of the system. This design prioritizes the security of the local machine over running the agent in the cloud. Because it requires these local compute resources to manage the virtual machine, the system is currently restricted to specific high-performance hardware. The agent only interacts with the host through intentional access paths, bridges that the user must explicitly grant for specific folders or applications. Physical isolation through this virtual machine is the primary safeguard preventing an autonomous model from damaging the host operating system. Within that sandbox, the system follows a specific logic to translate goals into digital actions. This is the Agent-Computer Interface, or ACI. It moves the user away from constant prompting and toward a model of objective-based delegation. This flowchart tracks the task loop. When a goal is assigned, the underlying model breaks that goal down into a sequence of actionable steps. The agent has two ways to execute a task. Method A uses the Model Context Protocol to provide fast, direct API connections to local tools. If a program lacks an API, the system falls back to Method B, Visual Execution. The agent takes a screenshot, analyzes the UI elements, and calculates the coordinates to move the mouse and click buttons. After every click or edit, the agent performs ground truth integration, reading the resulting state of the screen to verify success before moving on. This dual-method approach gives the agent the resilience to navigate messy digital environments that typically break traditional automation scripts. While these capabilities increase efficiency, they also create a new security paradox for enterprise risk managers. In an agentic system, the primary concern is no longer a human user trying to trick the AI into providing restricted information. The risk is defined by two factors: how much access the AI has to your files, and how much autonomy it has to take actions without your approval. When Cowork is granted full file system access to execute tasks independently, it operates in this critical zone. In this zone, the vulnerability moves from the user to the external data the AI ingests. As an agent processes more files, it becomes susceptible to a category of attack called Indirect Prompt Injection. We can observe this through a case study called the poisoned receipt. An attacker crafts a standard-looking PDF receipt, but hidden in white-on-white text in the bottom margin is a set of malicious instructions. When the user asks Cowork to process all receipts in my downloads folder, the agent opens the file and begins to read. This flow diagram shows the hidden text entering the model's context window. The injection overwrites the user's intent, commanding the AI to locate sensitive system files instead. The agent interprets the injected command as legitimate. It overwrites the task of processing the receipt and attempts to read the user's private SSH keys. If successful, the agent could exfiltrate those keys, granting an attacker access to the company's entire server network. This demonstrates that in an autonomous environment, standard documents can be weaponized to hijack highly privileged systems from the inside. How does the system prevent a poisoned file from actually reading those restricted keys? The first defense is a set of hard-coded permission tiers. These block the agent from accessing hidden directories or running shell commands without a manual approval from the user. The ultimate failsafe is an independent transcript classifier that monitors the agent's reasoning loop from the outside. This visualization shows the classifier in action. It strips away the language model's persuasive internal monologue and evaluates only the raw code payload. Because an infected model cannot be trusted to monitor itself, security must rely on these reasoning-blind filters to catch unauthorized actions. When we look beyond the security of a single machine, the broader impact of this technology becomes clear. Enterprises currently pay for per-seat licenses for hundreds of specialized software platforms, from legal review tools to expense trackers. CoWork's ability to navigate any UI means it can replicate those workflows using the user's existing local software. By using a simple markdown file called a skill, a non-technical professional can provide the AI with the procedural logic of a specialized application. The agent then executes that logic across your desktop, removing the need for the proprietary SaaS platform. This capability directly challenges the business models of the world's largest software providers. In February 2026, the release of role-specific CoWork plugins triggered a historic contraction in legacy software stocks, wiping out $285 billion in market value in a single session. This market reaction reflects a shift in the industry. High-margin, per-seat software is being displaced by localized agentic infrastructure. The future of enterprise IT is no longer just about managing software licenses. It requires mastering the governance of local sandboxes and securing the digital workers operating within them.